Hi, and welcome to Compski Corner. Today we're going to be talking about computational thinking. This video is specifically for the new OCR GCSE Computer Science course. However, it is applicable for most exam boards. Computational thinking is a problem-solving method where possible solutions are developed and presented in a way that can be understood by humans and computers. This is done by taking a complex problem, simplifying and understanding the problem, breaking the problem down, and presenting the solution in a way that can be understood by a human, computer, or both. This involves three principles of computational thinking that we're going to be looking at in this video, and these are abstraction, decomposition, and algorithmic thinking. Let's start off with abstraction. Abstraction is the simplification of a problem by removing unnecessary details of the problem. It reduces the complexity of a problem by creating a simplified model of reality. This makes the problem easier to understand, as the programmer can focus just on the key details of the problem. This means that the programmer has less to code and so saves resources such as time, money, and computational power. Abstraction is most easily understood when seeing it in action, so let's look at a few examples. Think about the map of the London Underground. It is an abstraction of reality because the different stations are presented by symbols. Irrelevant details, such as other buildings in London, have been removed, and color coding has been used. All these features reduce the complexity of the map, making it simpler and easier to understand. Similarly, if we were creating a virtual driving game to help people learn to drive, to tackle this problem, we could simplify the scenery, use symbols to represent the road signs, and remove some of the smaller roads. By doing this, the user will focus on the important aspects of the game and not be distracted by other unnecessary details, and the programmer will have less to program. However, too much abstraction could detract from the appeal of the game, or it might make the game too simplistic and not realistic enough. The TCP/IP model is another example of where abstraction has been used. Decomposition is the breaking down of a complex problem into smaller subproblems. This makes the main problem easier to understand and solve, as the problem can be divided between a team of people, where each programmer works on a separate subproblem, so that the most can be made of their particular area of expertise. Breaking the problem down into different individual parts means that one of these parts of the program can be edited or changed without affecting the rest of the program, making it easier to write, test, and maintain the program. As we did with abstraction, let's look at an example of decomposition. If our problem was developing a car, we could break this down into smaller subproblems, such as designing the front of the car, the back of the car, the interior, and the exterior. Then, different people could focus on each of these subproblems. They could create and test a solution to each, and then we could combine each of these solutions to the subproblems to create the solution to the original problem. Another example of decomposition is, again, the TCP/IP model. The model has been divided into 4 layers that work independently of each other, so that if one layer needs to be changed, it can be done without affecting the other layers. The last principle of computational thinking that we're going to be looking at is algorithmic thinking. First, it is important to understand what an algorithm is. An algorithm is a set of step-by-step instructions used to solve a problem. This could be the steps to make a cup of tea, or a procedure to make a computer add 2 numbers together. Algorithmic thinking is applying a step-by-step process, or an algorithm, to solve a problem, so that the problem can be understood by humans and computers. This could involve developing a series of step-by-step instructions, which make the solution easier to follow, and thus the problem easier to solve. For example, if you were trying to get from one place to another, you would follow the instructions on the sat-nav or Google Maps. In this video, we have looked at computational thinking and some of its main principles, including abstraction, decomposition, and algorithmic thinking. If you have enjoyed this video, then please be sure to give it a big thumbs up and subscribe to my channel for more. See you next time. Bye!